Ever been so perfectly aligned with someone you know, a friend finishing your sentence? Or maybe a bandmate hitting the exact same note?
Oh, yeah, absolutely. Or like teammates just moving in perfect sync on the field.
Exactly, that feeling.
Okay.
It's almost like your brains are literally connected, right?
Ah.
Well, science is increasingly showing that's not just a feeling, it's actually measurable.
Mm-hmm.
Welcome to the deep dive. Today we're not just talking about being on the same wavelength. We're really diving into the science of inter-brain synchronization. IBS, for short.
Oh, right. And specifically how new technology is trying to, well, maybe amplify that connection.
For this deep dive, we've really zeroed in on a specific research paper. Pretty groundbreaking stuff.
Yeah, it's called NeuResonance, Exploring Feedback Experiences for Fostering the Inter-brain Synchronization. Comes from researchers at the University of Maryland and Texas A&M.
So our mission today,
Yeah.
figure out what IBS actually is.
And then how these scientists tried to boost it using different kinds of feedback, like visual, audio, even touch.
And crucially, what could this all mean for teamwork, communication, maybe even physical therapy?
That's the plan.
So the big question we're tackling is, can we genuinely get a shortcut to being in sync with someone?
And, if we can, which way works best? Visual, audio, haptic.
The answers might actually surprise you.
Yeah.
Okay, let's get into it.
Let's do it.
So inter-brain synchronization, IBS. When we talk about this phenomenon, what exactly are we talking about? Are our brains literally syncing up?
Yeah, pretty much. When people work together on something, a shared task, their brain activity patterns often start to mirror each other. They synchronize.
Wow.
And it's not just, a coincidence or some kind of metaphor. It's a real measurable neural thing. We've seen these shared patterns in, well, all sorts of cooperative activities.
Like what kind of activities show this? My mind jumps to musicians playing together, obviously.
Sure, musicians are a classic example, but it's actually much broader. Studies have seen it when people watch the same movie together.
Oh.
Yeah, or perform coordinated hand gestures, play online games together, even simple things like just holding hands or working on a puzzle together.
Or, I think I read, collaboratively typing something.
Exactly, collaboratively typing passages. It really shows how our brains kind of automatically try to find a rhythm with another person when we're focused on the same goal.
That's pretty amazing. But, okay, why does it matter? Is it just a cool scientific observation, or does this brain sync actually have an impact?
Oh, it definitely has an impact. This is where it gets really interesting, I think. Past research shows pretty clearly that IBS isn't just happening in the background. It's deeply connected to positive social stuff.
Positive social stuff, like what?
Like stronger feelings of closeness, trust between people, even empathy. It seems to foster what researchers call behavioral coordination.
Okay, like moving together smoothly.
Exactly. Think of dancers or rowers. And it boosts the sense of joint agency, that feeling of we're doing this together as a single unit.
Right, that we feeling.
And being able to measure this sync, it might even help predict how well a collaboration will go. It helps us understand those, subjective parts of working together.
Okay, so brain sync is definitely a good thing. Makes sense. Which naturally leads to the next question.
Yeah.
Can we, make it happen more? Can we boost it?
Oh, yes.
Especially using ways that, everyday people could potentially access, not just lab equipment.
That is precisely the big question this NeuResonance paper dives into. We've known for a while that IBS correlates with good outcomes, but actively enhancing it. That's been relatively unexplored territory.
Especially with external feedback. Right?
Exactly. There's been some work using things like magnetic brain stimulation, which is not exactly user-friendly.
No kidding.
So this study focused on things like visuals, sounds, vibrations, much more accessible.
So if we could reliably strengthen this sync with feedback.
Yeah.
Wow. What are the potential implications there?
Oh, they could be huge. Really huge. It could lead to totally new ways of working together in teams, creating synergies that maybe go beyond what individuals can do alone. Think about education students tackling complex problems together. Or in companies, improving teamwork and communication.
Or even therapy. You mentioned that earlier.
Yes, definitely. Imagine strengthening the connection, the rapport between a therapist and a patient. It could really open up some new possibilities for connection and collaboration.
Okay, so that's the potential. Let's get into the experiment itself. NeuResonance. How did they actually try to sync people's brains? What was their main hypothesis?
Well, their central idea, their hypothesis was basically If we give people real-time feedback about how in sync their brains are using visuals, sound, or touch, will that feedback itself increase the level of synchrony?
So can these external cues actively push the brains to sync up more?
That's the core question they wanted to answer.
And measuring brain sync in real time. That sounds incredibly difficult. How do they pull that off?
It is complex, yeah, but they had a pretty smart setup. They used dual EEG.
EEG, like the caps with electrodes.
Exactly, electroencephalography. Reading the brain's electrical activity. They used these specific headsets, emotive epoxy X, on 2 participants at the same time.
Okay.
And to make sure the signals were clean, because people move, right? They used a Vicon motion capture system.
Like for movie CGI?
Kinda, yeah. It helped remove the noise from physical movements, so they were getting cleaner brain data.
Clever. And then how did they calculate the actual sync level?
They used a measure called the circular correlation coefficient, or C-core. You can think of it as a way to measure how well the phases of the brain waves from the 2 people line up.
Phase angles, like the peaks and troughs matching up.
Precisely. A higher C-core value, closer to 1, meant the brain waves were more aligned, more in sync, and their system was pretty fast. It could calculate and output a new C-core value every 1.5 seconds.
Wow, near real time then. So they've got this number representing sync. How did they turn that into feedback people could actually perceive?
Right, that was the next challenge. They designed 3 different feedback systems, all dynamically changing based on that C-core score, with 5 levels of intensity.
Okay, what was the first one? Visual.
Yep, visual feedback. They used projection mapping for this. They projected an abstract image, an oscillating orange circle, directly onto the participants' bodies.
Onto their bodies. Interesting. How did it work?
The idea was, as the IBS, the brain sync, increased, the wobbling or oscillation of that orange circle decreased.
So more sync meant a calmer circle.
Exactly. The goal was a perfectly still circle when they were at maximum synchrony. It was designed to be, spatially there with them and hopefully not require too much mental effort to understand.
Okay, sounds fairly intuitive, like a visual gauge for calmness or alignment. What about the sound? How do you make brain sync audible?
For the auditory feedback, they mapped the IBS score to the pitch, the frequency, of one note within a musical chord.
A chord.
Yeah, they used a major triad, typically a stable, pleasant sound. 2 notes of the chord stayed the same, the root and the fifth. But the middle note, its pitch would shift based on the sync level.
So if you were out of sync...
If your synchrony dropped, the frequency of that middle note would decrease slightly, just a 5% shift for 1 level down. This made the chord sound a bit off, less harmonious.
Like instruments tuning, but maybe going out of tune if you weren't synced.
Kind of like that, yeah. The idea was to guide people using relative pitch, even if they weren't musicians. It was played through stereo speakers. But yeah, the question remained, how easy is that for non-musicians to pick up on?
Good question. Okay, visual auditory was the third one. Haptic.
Haptic feedback, yes. Using vibration, they had participants wear vibration bands on their wrists.
Like a smartwatch vibrating.
Sort of, yeah. The feedback here was based on rhythm and intensity. Lower synchrony, more dissonance, meant faster beats per minute, faster pulsing, and stronger vibration.
In higher synchrony.
Higher synchrony meant slower, gentler vibrations. Slower BPM, lower intensity.
What's interesting about haptics? Does it have advantages?
Well, one big advantage is speed. You feel vibrations almost instantly, like within 150 to 200 milliseconds. So it's quick, grabs your attention,
right.
And it does that without necessarily pulling your visual focus away from a task. And it's silent, so it maintains privacy.
Okay, 3 very different ways to feel the sync. So how did they test these out? What did the actual user study involve?
They recruited 34 people, put them into 17 pairs, mostly strangers to each other.
Okay.
And these pairs did 2 different tasks together. One was simple, hand mimicry, just copying each other's hand movements.
Simple enough.
The other was trickier, the cup and string task. Where you have multiple strings attached to a rubber band and you have to work together to pick up and move cups using only the strings.
Oh, I know those. They require serious cooperation, like building IKEA furniture with someone, but maybe harder.
Exactly. Both tasks were chosen because they really demanded cooperation, coordination, and paying attention to each other, joint attention.
Makes sense. So what conditions did they compare?
They had a baseline non-sync condition where people just watched a video, expected low IBS there. Then they had the collaborative tasks with 4 variations, no feedback at all. Then with visual feedback, auditory feedback, and haptic feedback.
And they measured more than just the brainwaves.
Oh, yeah. They used questionnaires after each trial asking about trust, how helpful the feedback felt if they understood it, and then longer interviews and surveys at the very end.
Or the moment of truth. After all that setup, all that data, what actually worked? Did any of this feedback actually boost brain sync?
First off, they checked their basics. And yes, their setup worked. IBS levels were definitely higher during the collaborative tasks compared to just watching a video, so they could measure the effect reliably.
Good start.
Then the hypotheses about the feedback, well, visual feedback. Hypothesis 1 was that it would increase IBS. That was false.
Really? It didn't work.
Quantitatively, no. It didn't show a significant improvement over getting no feedback at all. Kind of surprising, maybe.
Huh. Okay, what about auditory?
Auditory feedback. Hypothesis 2. It increases IBS. That was true. This one was actually the clearest winner. It had the most substantial, most consistent positive effect on boosting synchrony.
Interesting. Okay, and haptic.
Haptic feedback.
Yeah.
Hypothesis 3. It increases IBS. Also true. Haptic feedback did positively influence the intensity of the brain sync.
So visual was a bust, but auditory and haptic both helped.
Pretty much. And the overall hypothesis, H4, that external feedback in general can augment IBS, that was also true. Having some kind of feedback was generally better than none.
So yes, you can nudge brains into syncing better with external cues. That's a big finding.
It really is.
But, the numbers are one thing. What did the people actually think? How did it feel to get this feedback?
Yeah, the qualitative stuff, the interviews, that added a lot of important nuance. For visual feedback, remember the orange circle?
Yeah.
A lot of people, 20 out of the 34, actually found it distracting.
Distracting. How so?
Well, they felt they had to split their attention visually between doing the task and watching the feedback projection. And often, if they got really focused on the task itself, the visual feedback just sort of faded into the background. They stopped noticing it.
Ah, okay. So maybe okay for simple stuff, but not when you really need to concentrate.
That seems to be the case. Some found it clear for simple movements, but less helpful for the complex cup task.
Right. And haptic. The vibrations, you said that also works quantitatively.
It did, but it was really polarizing subjectively. People seemed to either love it or hate it.
Oh.
Yeah, it was the most favorite for 13 participants, but the least favorite for 14 others. Pretty split.
Why the strong reactions?
Well, those who liked it initially described it as calming, intuitive, less stressful. Some felt it helped them trust their partner more. One person specifically said it helped them focus more on watching their partner, which helped them sync up.
Okay, that sounds positive. So why did others dislike it?
The main complaints were that the effect could wear off like sensory adaptation. You just get used to the buzzing.
Yeah, like tuning out your phone vibration.
Exactly. Or they found it too intrusive, or actually hard to notice the changes in vibration, especially if the baseline intensity felt too strong to begin with.
Tricky to get that balance right. Okay, so that leaves auditory, the quantitative winner. How did that land with participants?
Auditory was much less polarizing. Generally, people preferred it. They described it as distinct, beneficial. They liked that it gave instant, delay-free responses.
The immediacy was key.
It seems so. It let them keep their visual focus entirely on the task and their partner. And people with some musical background often found it especially easy to understand.
Makes sense. Any downsides?
A few people found it a bit intrusive or sometimes confusing, like if the sound indicated they were out of sync, but they felt like they were perfectly in sync with their partner.
That could mess with your confidence a bit.
Right, it could reduce confidence momentarily if the feedback didn't match their own perception.
That brings up trust again. Did they look at which feedback type people trusted the most to be accurate?
They did, and this was another really key finding. Auditory feedback came out on top as the most trusted signal for synchrony.
Okay.
Followed by haptic, and then visual was seen as the least trustworthy.
Interesting.
But here's something even more fascinating. Pairs, where both people happen to share the same top preference for a feedback type.
Yeah.
They actually showed significantly stronger synchrony when using that preferred feedback. Their IBS scores, the C-core values, went up by an average of 14% compared to the no feedback condition.
Wow. So personal preference really matters here. It's not just about the modality itself.
Exactly. It highlights how important user preference and maybe even shared expectations could be when you're designing systems for connection.
That's a massive takeaway for anyone building collaborative tools or experiences. So pulling this all together, how should we think about using this feedback? How do we tailor it?
Well, the results give us some pretty clear pointers. Auditory IBS feedback seems like a really good general purpose choice, especially for tasks involving movement, because it doesn't really interfere with your eyes or hands.
Right.
But obviously it's not great if you're in a noisy place or if the task itself involves critical listening, like playing music or having a conversation.
Okay, so where auditory doesn't fit, haptic comes in.
Exactly. Haptic IBS feedback is a fantastic alternative then. It's silent, not bothered by noise, keeps things private, doesn't interrupt conversation.
But you need to be careful about the task, right?
Definitely. You wouldn't want it interfering if the task itself relies heavily on fine-tuned feelings in your hands or fingers, like intricate crafting, maybe surgery.
Yeah, buzzing during surgery seems like a bad idea.
Probably not ideal, no.
So, thinking about real-world applications, where could we see this being used effectively?
Well, you mentioned physical therapy earlier. I think that's a great example. Imagine using auditory feedback to help strengthen that connection, that therapeutic alliance between a therapist and patient.
Yeah, it could boost motivation, maybe make it feel less clinical, more like a team effort.
Precisely. Enhancing comfort, that sense of togetherness, while the patient can still focus on the physical task.
What about something like brainstorming? Could this help teams gel better?
That's another really interesting possibility, maybe using haptic feedback there.
Why haptic?
Because it could subtly enhance those feelings of closeness and trust, maybe make people feel more agreeable without getting in the way of the actual talking and idea sharing.
That's clever. Could that even work remotely, like over video calls?
Potentially, yeah. Imagine using shared haptic feedback to create a sense of shared presence, of immersion, even when people are physically apart, fostering that we're feeling across distances.
Okay, so wrapping this up, it seems like we've uncovered something pretty profound here about brain sync.
Yeah, we really took a deep dive into inter-brain synchronization today. It's this amazing thing where our brains literally get on the same wavelength when we collaborate. And this research showed pretty convincingly that, yes, we can actually enhance that connection using external feedback.
With auditory seeming to be the most consistently effective overall.
Great, but haptic showing its own unique strengths too, especially for privacy or when audio isn't suitable, and visual, well, maybe needing a rethink.
It really makes you wonder, doesn't it? What if future tech could truly personalize this? Like feedback that adapts not just to the task, but to your specific sensory preferences, maybe even your partner's.
Imagine that. A future where you don't just feel like you're in sync, you have this subtle, unobtrusive feedback confirming that you are. Measurably.
How different would collaboration be?
Yeah.
Or learning? Or just connecting with people, whether they're right next to you or, on the other side of the world.
It definitely gives you something to think about. A future where we're consciously, technologically enhancing our connections. Well, thank you for joining us on this deep dive. We hope it's given you a bit of a shortcut to understanding IBS and maybe sparked some new thoughts.